Let's take a look at angles in their measure. I get my recording going here. There it goes. Move that over clear over there. Now, first thing, let's talk about degrees. This is a way to measure an angle. Now, angle, you have your starting side, your initial side, and then you have your terminal side, like that. And this measure inside here, how much it opens up, is going to be your angle, and I'll label it as theta. That's Greek letter. And for example, this right here, theta might be 45 degrees. Now, to give you an idea, here's my initial side, straight up, forming a 90-degree angle here. Looks like that. If I'm starting here, and I go clear over to here, that right there, that's 180 degrees. When I said this is 45, it kind of looked like maybe it's halfway there, roughly. And that's like that. If we start here, and you end up down here, going like that. Well, you notice how this went from 90 then to 80? Well, we're going to add another 90, and that's going to give us 270 degrees. And then, if I'm starting here, and I go all the way around, I end at the same place, that's 360 degrees. 360 degrees takes you back around to your beginning. And that's degrees. Now, we have another way of measuring an angle called radians. And to give you an idea here, here's my initial side, and here's my terminal side. Remember, this was 90 degrees in degrees. In radians, this would be pi over 2. If I start here, and I end up over there, remember that was 180 degrees in 180 in degrees. This would be pi in terms of radians. And if I right here and I end up down here, there you go. Now here I went from pi over 2 and then I went to pi. I basically added another pi over 2. Pi over 2 plus pi over 2 will give us 2 pi over 2 or pi. So I keep adding another pi over 2. You know, this right here is the same as 2 pi over 2. So this is 1 pi over 2, 2 pi over 2, 3 pi over 2. And then if I start here and I go all the way around, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, or 2 pi. So all the way around is 2 pi. So we're going to find, and we'll do this this here in a minute, but 360 degrees is the same as 2 pi in terms of measure. Also, 180 degrees is equal to pi. This specifically is one we're going to use to help come up with a formula to go back and forth between degrees and radians. Okay, so let's look at our first problem. It says draw each angle, and it asks us to draw 120 degrees. Okay, so here's our starting place. Now up to here would be 90. And over to here would be 180. Between 90 and 180, well, anyway, in any of these quadrants, we'd have 90 degrees. If you divide that by 3, each one would be 30 degrees. Not that I can really eyeball these very well and split them exactly. That's as close as I'm going to get. So each one of these is 30 degrees. That's 30, this is 30, and this is 30. So if I got 90 here and I want 120, I'll go to another 30. So that right there will be 120 degrees. And I'll kind of sketch it over here on the side since we don't want all that extra junk. I was just using it to show it. That's probably as good as I can do without putting the other on there. That's 120 degrees. Okay, so our second one. 2 pi over 3. Now keep in mind, this was our starting place here, and if I went all the way over to here, that would be pi. This is 2 pi over 3, so 2/3 pi. Well, if I split this into thirds, if I can actually eyeball this. Not real good, but probably as good as I'm going to do without some kind of measure. So that's like a third, this is a third, and this is a third. Use your imagination. So if this is our initial side, then 2/3 pi would be over to here. So that's 2 pi over 3. We're going to take a look at something called a unit circle here after a while, and well, not in this section, but a little bit to help understand the concept of those. Now I got 19 pi over 4. Let's change this to a mixed number. 19 divided by 4 is 4 with a remainder of 3. So we change it to a mixed number, and that tells us we got 4 and 3/4 pi. Well, let's first talk about this. Okay, so we got this right here. This is our initial side. Remember, we go all the way around. That's 2 pi. Well, if I go here, that's 3 pi. Here is 4 pi. And if I go up here, that's 4 1/2 pi. So 4 3/4 pi would be over to right here. I'm not going to sketch that separately. But see how we go around like that and end up there. So that's our 19 pi over 4. Now it doesn't look like I came up with an example of this, which is a shame. But if I look at like negative pi over 2, here we were going counterclockwise. If I got negative pi over 2, and I didn't mean to put all that junk in there. Okay, try that again. Here's my initial side. Pi over 2 would be up to right here, so negative pi over 2 would go clockwise, and it would end up right there. So that's negative pi over 2. Now you'll notice that right there, if I had started here and went this direction, that would have gave me the same terminal side, and we'll talk more about that later, the coterminal, what that means and so forth. But there's more than one way to measure this. You can have a negative, or you can have this right here, which would give us a positive. And let me save that page. And what is this called? Degree angles in their measure. So angles in their measure. Trig angles and their angles and measures. Part 1. Why didn't put page 1? Oh well, there it is. Okay, so let's talk about this next item. We said this little mark here represents degrees. And by looking at the different examples we've had, you kind of get a feel for what 45 degrees would be, 30, so forth. Now we have a little mark looks like that, and that's minutes. And basically, 60 minutes equals 1 degree. It's a finer way of measuring. Then if you got two little tick marks like that, you probably kind of guess what this is. Seconds. And what we'll find here is 60 seconds. Guess. It's pretty simple. 60 seconds is equal to 1 minute. And 360 seconds is equal to 1 degree. So this next problem says convert each angle to a decimal in degrees. Round your answer to 2 decimal places. So I got 35 degrees, 24 minutes, and 14 seconds. And convert each angle to a decimal in degrees. Well, this right next to each other like that means that's 35 degrees plus 24 minutes plus 14 seconds. Now to convert this to, and you can memorize formulas all day long, but it's really a lot easier than that. Think if this was 60 minutes instead of 24 minutes. 60 minutes, or there it is. 60 minutes is 1 degree. So you think, what would I do to get that to degrees? We divide by 60. 60 divided by 60 gives you 1. So to convert that, we're going to do 24 divided by 60, and that changes that to degrees. Now for our seconds here. Well, here we said 3,600 seconds is equal to 1 degree, so we're going to divide this by 3,600, like that. Now this is 1 in decimal, so I'm not going to put a lot of time into getting an exact answer. It says round to 2 decimal places, so let me pull up my calculator. Should have had that up and running, but oh well. And exit out there, second mode, clear. And we got 35 plus 24 divided by 60 plus 14 divided by 3,600. And press enter, and we get 35.40. 4040. And that'd be our answer. Next problem. We got 42.32 degrees. And the instructions say, convert each angle to degrees, minutes, and seconds form. Round your answer to the nearest second. Okay. Well, what this means is we got 42 degrees plus 0.32 degrees. Now, think what we did up here. We went from minutes and changed it to degrees, and we divided by 60. Well, to change this to back to minutes, if we divide going that direction, here we're going to multiply by 60. So we're going to take 42 plus 0.32 times 60, and that's going to put it back into minutes for us. Well, got my calculator running. I might as well just plug it in there instead of doing it by hand. I used to think too hard this late at night. 0.32 times 60. 19.2. Which means this is 42 degrees plus 19 minutes plus 0.2 minutes. Now, we don't want decimals. That's why I split these apart like this. So this is good, but this we need to change to seconds. Now, it's already in minutes, so we don't want to multiply by 3600 because we just need to take it one step because we're going from minutes to seconds. So we're going to multiply this by 60. So 60 times 0.2. Now put it into seconds for us. So we got 42 plus 19. And I think that's 12, but let me go double check. I'm not very good with decimals. 60 times 0.2, especially I'm getting tired. 12. Okay. Which means our answer here is 42 degrees, 19 minutes, and 12 seconds. I didn't have to do any rounding there because it came out perfect, which is weird because I made that number up. I didn't actually work this problem ahead of time. So weird it came up nice. Now, these next problems are asking us to do a conversion from degrees to radians. So let's talk about, I could give you a formula to memorize, but I'm going to really approach these with dimensional analysis. And so let me write this problem down. I like dimensional analysis because it doesn't require much thought. You don't have to sit there and memorize a formula. Okay, so convert it to degrees to radians. Express your answer as multiply pi. Means no decimal places. And pretty much in trig, we don't want decimal places unless it specifies. To use dimensional analysis, you always put this over 1. And whatever unit measures up here, which is degrees, is what goes down here. Now remember before what I said. I said 180 degrees is equal to pi radians. So I'm going to put 180 here, and up here I'm going to put pi. Now I'm going to put radians here. I'll put rad for that. Technically you don't need that. If there's no unit measure, then it's by default radians. But I just want to really emphasize it. Now when I do this, the degrees symbols will cancel. And we got 85 pi over 180. Top and bottom will at least both divisible by 5. What's that? 17. Let's see. Yeah, 17 pi. And let's see. 36. Yeah. So this would be our answer. 17 pi over 36. Okay, so let's look at this one. Convert each angle in degrees to radians. So we got negative 120 degrees. And again, I'm going to use dimensional analysis, so I'll put that over 1. And if degrees is up here, then degrees has to be down here. And this is the best relationship we have. You could use 360 degrees equals 2 pi, but that gives you extra work you don't need to do. And again, this is pi radians up here. I won't actually put a radians because, like I say, you don't need them. The degree symbols will cancel. And we got negative 120 pi over 180. They both end with 0, so I can go ahead and get rid of that real easy. So I got negative 12 pi over 18. Top and bottom both divisible by 6. So that gives us negative 2 pi over 3. There's our answer. I hate when in books they actually give formulas for this because it's so easy using dimensional analysis. You just have to remember that key fact that I mentioned. This says convert each angle in radians to degrees. Well, again, I'm going to put radians here just to really emphasize it, and I can put that over 1 if I need be. And if that's radians up here, this has to be radians down here. So put pi radians here. And again, we said pi is equal to 180 degrees. So 180 degrees goes up there. Well, the radians cancel. And of course that 1 doesn't do anything, so I'm going to go ahead and drop it. So we got pi over 3 times 180 degrees over pi. the pi's also cancel. And we got 180 degrees over 3, which gives us 60 degrees as our answer. Okay, so let's look at this one. 51 degrees. And it says, convert each angle in degrees to radians, express your answer in decimal form, rounded to 2 decimal places. So, don't want to do any simplifying here. We can just plug it straight in our calculator. Now again, we're going to radians, I believe. Yeah. So I'll put this in fraction form. And if I have degrees up here, I have to have degrees down here. So I put 180 degrees there, and pi radians would be up here. Well, yet again, the degrees will cancel like that. And we got 51 pi over 180. And we're just going to plug this in our calculator because it wants a decimal. So, what did I say, 51? Yeah, 51. And pi, my eyes are bad. I think it's above caret. I do second caret. Yeah. Then divided by, and 180. And enter. And, round to 2 decimal places. Okay, so this would be, our answer would be 0.89. Now we're in radians, so I don't need to put any kind of mark here. If there is nothing, then it's by default radians. Let me save that. There we go. And one more of those. Then we'll go look at the next type of problem. Let's see, square root of 3. And of course, without even reading the instructions, I know this is radians because there's no mark of any sort. So this is square root of 3 radians. It says convert each angle in radians to degrees. And it's calculator 1 again. Let me put radians here just to really emphasize it. Again, we want it in fraction form. And if I put radians up here, I have to put radians down here. And so this would be pi radians, and I put 180 degrees up there. And of course, those are gone. And up on top, we have square root of 3 times 180 degrees over pi. So, square root of 3. I'll do second x squared and put 3 in, closing parentheses, times, try it again, times 180, divide by pi. So divided by, and then second caret for the pi. And I think it was, what, 2 decimal places probably? Around 2 decimal places. Okay, so 99.24. We'd round. And that would be our answer in degrees. Now these next ones revolve around. If we got a circle here, and we got a radius, and we got an angle, and this S would be this distance right here. Some of these problems will ask us to find S. Some may find R. I don't think any of them ask us to find theta. That's more later on. But let's look at some problems revolving around that. Okay. So they tell us R is equal to 3 feet. Theta is equal to 4 radians. Again, I'm going to just put 4 because I don't need to put radians. It's by default. If there's no measure there, it's radians. And it says S denotes the length of the arc of the circle of radius r subtended by the central angle theta. Find the missing quantity. Round answers 3 decimal places. Formula is S equals r theta. Okay, so let me scroll down here. Now for this formula to work, theta must be in radians. So if it's not in radians, you need to convert it. Let me put a little asterisk by that. This problem's okay. Theta's in radians. So, see, r we said was 3 feet. And theta we said was 4 radians. So, got 3 feet times 4, so S is going to equal to 12 feet. And that's our answer. Now this next one, we actually have to do the conversion. So let's take a look at it. We got r is equal to 7 and 7 meters. And theta is equal to 60 degrees. Well, theta has to be in radians, so let's convert it. We got 60 degrees, I'll put over 1. And again, use dimensional analysis. Degrees is here, so degrees has to be down here. So I got 180 there, and this would be pi radians. Degree symbols would cancel there, and we got 60 pi over 180. Top and bottom both divisible by 60. That gives me pi over 3. And that's theta. So theta is equal to pi over 3. And again, that's what we have to have it in. Plug in this formula. So S is equal to r theta. R is 7 meters. And theta was pi over 3. Round answers are 3 decimal places. Okay. So we end up with 7 pi over 3 meters. But they want us to put that into decimal. So go to my calculator. 7 and second caret for pi, divided by 3. Enter. No memory at all. What did I say? 3 decimal places. Okay. So 7.330. So 7.33 meters. And that's our answer. Now we also have a formula for the area, which is the next problem. So let's look at it. Area is equal to 1/2 r squared theta. And let's see, A denotes the area of the sector of the circle of radius r formed by the central angle theta. Find the missing quantity. Round answers in 3 decimal places. So in this one they tell us theta is equal to 1/5 radians. So theta is equal to 1/5. And A is equal to 4 square centimeters. So A is equal to 4 centimeters squared. It's easier to work with this math-wise in this form. Now again, to use this formula, theta must be in radians. If it's not, you have to convert it. Which is okay, this is already in radians, so we're fine there. So let's just plug in everything. Oops. Try it again. A is what they give us. So this is 4 centimeters squared equals 1/2 r squared. We're missing the r, aren't we? So that's what we got to find. And theta is 1/5. So we got 4 centimeters squared. 1/5 times 1/2 is 1/10 r squared. Try and get the r by itself, so we'll multiply both sides by 10. And we get 40 centimeters squared equals, those 10's cancel, and we got r squared. Now we're solving for r, and r can never be negative. Normally this would be the square root property. We'd drop our squared off of our r and we'd put a plus or minus square root on the other side. But we don't need to put the plus or minus because we know it can't be negative. So we're just going to do the square root of 40 centimeters squared. Now, random answers are 3 decimal places. Let me find the exact answer first. 40 is 2, 4, 8, 40. And centimeters squared. Well, that means centimeters times centimeters. Now remember with square roots, we're looking for pairs of something. Here's a pair of 2's. That's going to come out as a single 2. Here's a pair of centimeters. That'll come out as a single centimeter. So we're going to have 2, and I'll put it out in front temporarily. And then inside we got 2 times 5, which is 10. So our answer will be 2 square root of 10 centimeters. But let's see what the calculator gives us. So I'm going to do 2, and then second x squared, and it's 10, and enter. And I think it's 3 decimal places, so 6.325. 6.325 centimeters. And that's our answer. Let me save this and start a new page. I think we're down to our last problem, but I'm not sure if I actually have room there. And time for that to blow up, so I'll bring up another. There we go. Okay, so on this one, they're giving us that theta is equal to 60 degrees. They're giving us the picture. We just have to pick out the pieces. This angle here is 60 degrees. This distance here is 10 centimeters. That's R. And they give us the formulas here. S is equal to R theta, and A is equal to 1/2 R squared theta. Okay. Now remember, to use either one of these formulas, theta has to be in radians. It's not in radians. So let's convert it. So I got 60 degrees, put over 1. Again, degrees is up here, so degrees has to be down here. So I got 180, and then radians would be up here. The degree symbols will cancel. And obviously I don't have very much imagination. I did this one earlier, didn't I? Both of these are divisible by 60. So that gives us pi over 3. And now we have our angle in radians. So to find S, R times theta, R was 10 centimeters. Like that. So that'd be 10 pi over 3 centimeters. 10 pi. So I got 10 second divide. Oops. Boy, it'd be nice to have my eyes again. Second caret. I actually have my glasses on. It's just a little bit too small for me. Divided by 3. Enter. And 3 decimal places, I'm assuming. 3 decimal places. So I got 10.472 centimeters. And our A. Well, R we just said was 10 centimeters. And theta we said was pi over 3. Now when you got items inside of a parentheses and they're separated by multiplication or division, they don't have to be numbers. You can have anything. See how this is 10 and like centimeters right beside it? You can think of this as multiplication. But if everything's multiplication and division inside, you can take everything to that power. So you can take the 10 to that power and the centimeters to that power. So this gives us 1/2 times 10 squared, which is 100, times centimeter squared, which is centimeter squared, pi over 3. Well, that gives us 50, 1/2 times 100, centimeter squared times pi over 3. So that gives us 50 pi over 3 centimeters squared. And let's plug that in. 50, and where in the world did I say pi was? With the caret, I think. Second caret. Yep. Divide by 3. Enter. And we got 52.359. We round up, so that gives us 360 or just 36 square centimeters, or centimeters squared. And those would be our answers for that problem. And I think that's our last one. Yes, it is. So let me save this page. That was interesting. And then I'll stop the recording here on both WebEx and Camtasia.